Hello, everyone. This is our final showcase. It's going to be by Matthew Sprinkle, Michael Smith, Blessing Ademo, and Jasmine Jones. For our final showcase, we are going to be analyzing the trends of the collisions of motor vehicles in New York City from 2012 to 2023. Here we have a detailed description of where the dataset was found and also its characteristics. The goal of this project is to analyze the trends in motor vehicle collisions in New York City between 2012 and 2013. We will be focusing on identifying areas with the highest crash rates, analyzing the time of day and month of year with the highest number of collisions, and identifying the streets with the highest rate of collisions. Now that we went over the scope and explanation of the project, here are some terms that you will see frequently in our showcase. Understanding these terms will help you understand the showcase better. In February 2020, the first cases of community-transmitted COVID were reported within New York City. In March 2020, Governor Andrews signed an executive order that closed all non-essential businesses and pushed many organizations into utilizing work-from-home policies. This order included the temporary closure of bars, restaurants, sporting events, movie theaters, and concerts. Many schools were also closed during this time to stop the spread of the virus. From this graph, you can see that October and July are the months with the most number of collisions occurring. They are also 2 months with 31 days. If we look at the individual weeks instead of months, we can see that there's an upward trend of crashes that happens each week as the year goes on. We can also see that the first and last weeks of the month has significantly less crashes. In this graph of crashes by quarter, it is much easier to see the trend of more collisions happening towards the end of the year. Here you can see that between 2016 and 2019, the number of collisions that occurred on bridges, interstates, expressways skyrocketed, while at the same time collisions everywhere else went down. There are 5 boroughs in New York City: Staten Island, Queens, Manhattan, Brooklyn, and Bronx. Out of those 5, Brooklyn had the most number of accidents. These are the locations that exist inside of New York but outside of the boroughs. Generally, these are bridges. Driver inattention or driver distraction is the #1 contributing factor to motor vehicle collisions. Distracted driving collisions happens more than the number 2, 3, or 4 contributing factors combined. Here we see the crash incidents shown by the hour of the day. As you can see, the lowest number of crashes occur at 3 a.m. and the highest number of crashes occur at 5 p.m. during the evening peak. Motorists are the most frequently injured type of person in a motor vehicle collision. Interestingly, the number of cyclists and pedestrians injured does not fluctuate very much, regardless of where or how many motorists are injured. This graph shows the type of person, cyclist, motorist, or pedestrian, injured during the hour of the day. These graphs are showing the streets where the most accidents happen. The 4 streets with the most accidents are highlighted in the upcoming slides. The first street that we're going to highlight is 3rd Avenue. 3rd Avenue is 10.7 miles long, and the average collision per year is 2,089. The average collision per year per mile is 195. It connects Manhattan and Bronx. The next street that we're going to highlight is Atlantic Avenue. It's about the same as 3rd Avenue. It's a little bit shorter, 10.3 miles long. It's going to have a little less collisions from the mile and year and from the year altogether. It's going to average 1,538 per year, and it's going to average 149 collisions per year per mile. The third street that we're going to highlight is Broadway. Now this is longer than the two previous streets. It's going to be 33 miles long, and the average collision per year per mile is going to be 61 collisions, but the average collisions per year is going to be 2,017. It runs through Manhattan and the Bronx and exits New York City. Belt Parkway is our last street that we're going to highlight. It's 25.29. The last but not least street that we're going to be talking about is Belt Parkway. So Belt Parkway is it's longer than the first two streets that we mentioned, but it's not as long as Broadway. Broadway is the longest street that we had highlighted for the showcase. And the Belt Parkway is going to be 25.29 miles long. The average collisions per year is going to be 1,457. And this is actually less than the Broadway street, but more than others. And then the average collision per year per mile is going to be 58. Now this is less than all of the previous streets that we covered, with it only being 58 collisions per year per mile. It's going to connect Queens and Brooklyn, and then it's going to end at the JFK International Airport. So, based on our data and visuals we developed, we have generated 4 conclusions that is supported by our showcase. So, from the data on motor vehicle collisions, we have concluded that there are fewer collision occurrences in the first and last week of the month. That was supported by some of our previous visuals that we had. The second conclusion that we have generated is that the graph of crash by quarter supported that there are more collisions that happen towards the end of the year. The third conclusion that we have generated from our data on motor vehicle collisions is that out of the 5 boroughs, which was Staten Island, Brooklyn, Manhattan, the Bronx, and Queens, the highest number of collisions out of those 5 are going to be found in Brooklyn. But the most frequent place in New York City in general for collisions is outside of the borough, like we've seen for the bridges in previous visuals. So last is that the driver intention is the #1 cause for motor vehicle collisions. And the peak time that collisions occur is morning and evening rush hours. So that is all for our showcase. Thank you so much for watching. And please, if you have any questions or feedback, let us know.